Have you ever wanted to build your own photo filter app? One that's actually fast, responsive, and would look amazing in your portfolio? Well, today we're going to break down the architectural blueprint for a really solid photo app using SwiftUI and Core Image. This is a fantastic way to get some hands-on experience with some seriously powerful frameworks that are used all over the industry.
But that brings up the big question, right? How do you actually build a photo app that feels high performance? One that doesn't lag or just completely crash the moment you throw a big high-res photo at it. Well, that is exactly what we are here to unpack.
So, we're diving into the blueprint for what you could call a production-ready filter app. Think of this as a solid foundation. It's a guide to all the core pieces and smart tricks you'll need to build a project that'll really stand out, whether it's for your resume or just to sharpen your own skills.
Okay, first up, let's talk about the goal. What are we actually trying to build here? We're aiming for an app with the kind of features you'd expect to see in modern photo editors. It's a great project to tackle because it's challenging but totally achievable, and you'll get some great practical experience along the way.
So, what's the end result going to look like? Well, you're going to build an app that has a library of 8 different core image filters. Real-time rendering so you see changes instantly when you move a slider, and that really cool draggable before and after comparison view. Plus, it's built from the ground up with automatic memory optimization for stability, and of course, it has high-quality image exporting.
All right, let's pop the hood and take a look at the core filtering engine. This is really the heart of the app. It's where all the heavy lifting for the image processing happens, and it's all built on a really clean and powerful foundation.
To manage all the different filters, we're not going to use messy strings that can lead to typos and bugs. No, we're using a Swift enum called FilterKind. This is such a clean, type-safe way to do it. It defines every single filter we have, and it makes adding new effects later on super easy and, more importantly, safe.
And what filters are in our starter pack? Well, we've got a really nice selection here. You've got classics like sepia and monochrome, some really useful adjustments like vibrance, cool creative styles like the comic effect, and even utility filters like Gaussian blur. It's a solid toolbox that covers a ton of ground.
Now this right here, this is the secret weapon for performance. CI context with metal. What on earth is that? Okay, the best way to think of it is like a supercharged digital darkroom. Instead of making the phone's main brain, the CPU, do all the work, we're tapping directly into its graphics hardware. That's metal. It's like using a specialized muscle for a specialized job, and the result is incredibly fast image processing. This is how we get that real-time feel.
And here's what that looks like in the code. That first line, MTL creates system default device, that's literally us telling the app, hey, go find the graphics hardware and use it. Just as important is that little option below it. Cache intermediates false. That's basically us telling the app, don't be a data hoarder. It prevents it from holding on to a bunch of temporary image data, which keeps the app running lean and helps avoid those nasty crashes.
Okay, next section, adding that pro polish. This is where we get into the details that take an app from being just a simple demo to something that's truly stable and responsive. This is the kind of smart engineering that really makes a project shine.
Let's talk about the #1 killer of homemade photo apps, massive images. You try to load a giant 50 megabyte photo from a new phone and boom, crash city. It is a huge memory challenge. But this blueprint has a solution baked right in to stop that from ever happening. And I mean, just look at the difference. It's night and day. Without any optimization, you get crashes and a choppy, frustrating UI. But with the techniques we're using, the app can handle pretty much any photo size you throw at it, all while giving you that smooth, real-time feedback. That's the goal.
So, what's the magic trick? Well, it's this simple function right here. It's our safety net. Before we do any processing, it just checks the image's size. If it's bigger than our set maximum, here it's 2048 pixels, it intelligently scales it down for the editing process. This one step is the key to stability. And don't worry, when we go to export the final picture, we'll use the original full-quality image. This is just for the editing part.
Here is another really clever optimization. It's a technique called debouncing. Think about it. When you drag a slider, you don't want the app re-rendering the image 100 times a second. That would just grind everything to a halt. Instead, the app waits for a tiny fraction of a second, just 50 milliseconds, after you stop moving. If you move the slider again, the timer just resets. This stops the app from doing a ton of unnecessary work and keeps the UI feeling perfectly smooth.
Okay, so our engine is stable and performant. Now let's focus on what the user actually sees and interacts with. This section is all about building an intuitive and really satisfying user experience.
This blueprint uses modern UI components right out of the gate. For picking photos, it uses PHPicker View Controller, which is Apple's newest, privacy-first way to let users select photos without giving the app access to their entire library. And of course, it's got that slick, draggable before and after slider for instant comparisons. So, how in the world does that cool split screen effect work? Well, the core logic is all tucked away in this function, composite split. Now, the code might look a little complex at first, but the idea behind it is actually super straightforward.
It's a process called compositing. And really, all we're doing is taking two images, the original and the filtered version, and just cropping them. The original gets cropped to the left of where your finger is, the filtered one gets cropped to the right, and then they're stitched together perfectly to create that single, split view. It's a really powerful visual trick that's built on a pretty simple concept.
All right, we're in the home stretch. Now for the final section, taking this project from something in Xcode to a finished piece. This is all about adding those final touches, like letting users actually save their creations.
And the final step is, of course, exporting. This export image function is where we bring it all home. It takes the original, full-resolution photo, applies the filter settings you chose, and generates a final, high-quality image. It even handles asking for the right permissions to save it directly to the user's Photos library.
So, let's just quickly recap the key takeaways here. First, always resize big input images for editing. It's your best defense against crashes. Second, use Metal for hardware acceleration to let the GPU do the heavy lifting. Third, debounce your filter changes to keep that UI super smooth. And finally, please test on real devices with all sorts of different photo sizes. It makes a world of difference.
And there you have it. You've got the complete blueprint for a fast, stable, and feature-rich photo filter app. It is a fantastic starting point for learning these technologies and for building something that is uniquely your own. So the only question left is, what are you going to build with it?